Alright, here's 7-6 notes, equations from a graph. So today in class, if you weren't in class today, or if you didn't get to finish the warm-up in the first couple of minutes, here it is again, and I'll just show the slide with the solutions in case you want to double check, or if you weren't here you can kind of see what we reviewed a little bit from the beginning of the chapter. Alright, so now let's get to the actual notes. 7-6, finding an equation from the graph. So a couple of reminders. Slope-intercept form is y equals mx plus b. So you would use this if you were given the slope and the y-intercept, hence slope-intercept form. Because that's the easiest way to write that in an equation. We also have point-slope form of an equation for a line, and that would be, you would use that if you were given the slope and a point on the line, hence point slope. So it's kind of easy to remember which form you should use based on the information that it gives you. So here's point slope form. Your y minus y1 equals m times x minus x1. And remember, the x1 and y1 are the point given. Alright, so here are a couple of examples. It gives you some pieces of information about the line, so it's kind of like clues, right? This line has a y-intercept of 5 and a slope of 7, so you have to find that line. So if we wanted the equation of the line with a y-intercept of 5 and a slope of 7, we would want to use slope-intercept form because it gives us a slope and it gives us a y-intercept. So here I'll show you all of the answers now. And you know what? Maybe we could do a screen shade so that you're not focused on all of it at once. Alright, here we go. So we use slope-intercept form, and our slope is 7, so we substitute in for m, which is our slope, for 7, and our b is our y-intercept, so we substitute 5 for that. So our line is y equals 7x plus 5. So this next one contains the point 4, 7 and has a slope of 3/5. So we're given a point and a slope, so we want to use point-slope form. So that's your y minus y1 equals m times x minus x1. Remember, x1 and y1 is the point given, so your x1 is 4 and your y1 is 7. So let's substitute that in. We get y minus 7, right? All we did was substitute in 7 there, equals 3/5 times the quantity x minus 4. Alright, next one contains the point 1, 8 and negative 4, 2. So here it gives you 2 points. It doesn't give you an intercept and a slope or a point and a slope. So this one's a little bit harder because it's not so obvious which form you should use. But if it gives you 2 points, remember, you can use the formula for slope between 2 points to get your slope. So we use the slope is equal to y2 minus y1 over x2 minus x1. So I subtract 2 minus 8 divided by negative 4 minus 1. So our slope is 6 over 5. Now we have a slope and 2 points, so we can pick any one of those points and use it to write it in point-slope form. So I just picked the first point of 1, 8 and use that to write my point-slope form. If you use the second point, that would be okay too. Alright, now you try. So remember, the you try problems, here's the 3 right here that you can try on your own, and then I'll show you the answers. Alright. So let's take a look. The only thing I really want to point out to you is maybe number 2 in the point-slope form. Okay, so it contains the point negative 2, 1. So in here, when we substitute our x1 for negative 2, we have x minus negative 2. Remember, minus and negative becomes plus, so inside the parentheses here, it becomes x plus 2. Okay, and then everything else is just straightforward, like the first 3 examples, where your y1 was 1, so you have y minus 1, and then your slope is negative 6, so that equals negative 6 times x plus 2. And then again for number 3, first you have to find the slope between the 2 points, and then you can use your point slope form with either one of these 2 points. Okay, now we need to find the equation if we're given a graph. So here's the graph of our line. Okay, so you can either, identify 2 points on the line and do the same thing as what we did in example 3 here. Okay, find the slope between them and then use point slope form. Or you can find the slope and the y-intercept of this line and write the equation that way. I find it easiest just to do slope-intercept form and get the slope and the y-intercept here. So that's what I did for this one. So I just identified 2 points and found the slope between those 2 points. So my rise is 2, right, 1, 2, and my run is 2, 1, 2. So the slope is rise over run, or 2 divided by 2, which equals 1. And then my y-intercept is this point right here at 0, -2. So I know my b value is going to be -2. So if I substitute in for y equals mx plus b, my slope is 1, so I just get y equals x. And then my b is -2, so it's -2. Okay, now try this line. Alright, again, I like to use slope-intercept form. I think it's the quickest and easiest way. So I found my y-intercept here, so it crosses the y-axis at 1. So my b value is 1. And then the slope, I go down 1 and to the right 4. So my rise over run is -1 divided by 4. So my slope is -1/4. So I have y equals -1/4 x plus 1. So there's my y-intercept and there's my slope. Okay, now let's write the equation of this line. Sorry, the train's coming through. So try writing these 2 equations. One's a horizontal line and one's a vertical line. So if you want to draw it out on the coordinate plane first, maybe that'll help you out a little bit. Alright, so let's see what we have. Okay. So first, our horizontal line. So this is a horizontal line that contains the point 4, 3. So let's look at the coordinate plane here. Okay. Well, you know what? Let's not look at the coordinate plane yet. I think this is okay. If it's a horizontal line, we know that the slope is always 0. So our m is equal to 0. So we have a slope, and we also have a point because it contains the point 4, 3. So let's just use point slope form and substitute our values. So we get y minus 3 equals 0 times x minus 4. Now remember, 0 times anything is just 0, so we end up with y minus 3 equals 0. So let's just move the 3 over to the other side. So we get y equals 3 as our equation for a horizontal line. And if you notice, let's plot this line real quick. So we have the point 4, 3. So 1, 2, 3, 4. 1, 2, 3. So there's the point with the horizontal line. And then if our line is horizontal, it's going to go through this point like this. And what do you notice about all of the y values? All of the y values on this line are 3. So look at the equation, y equals 3. So it doesn't matter wherever you put the x, the y value will be 3 for this horizontal line. Now the vertical line. So we have a vertical line and it contains the point -2, 0. So we know that for vertical lines the slope is undefined. So you can't use point slope or slope-intercept form because you can't substitute anything in for the slope. So this is actually a special type of equation. We have a special way of writing this. We know that it contains the point -2, 7. So let's take a look at that on the coordinate plane. We'll use a different color. We'll use red. So -2, 7. right here. Okay, bear with me in my drawing with my trackpad on my computer. And now we have this line, which is a vertical line going through that point. So remember with the horizontal line, all the y values were 3. What do you notice about this vertical line? Yeah, all the x values are -2. So to describe this line, our equation is going to be x equals -2, because that is always true no matter where you are on that vertical line. Alright, and I think that's it for this set of notes. Yep.